Hello everyone. So in this live hands-on exercise, we will go through some of the questions on the pandas concept. So before we start doing any analysis using the pandas, make sure that we import the packages. So let's import here. So we have imported the package, and now we can go ahead and start working on the questions. So the question number 1 it's saying is that load the CSV file in pandas data frame and find their statistical descriptions and display their first 10, last 10 and random 10 samples. So the file what we have in the Excel, let's read that file which is this one. So this is how we can read any CSV file, and the CSV file I'm storing into the variable df. So the file has been loaded into a data frame like df. So the next step what we can do is to find the first 10 observation of this data frame. So we can do using the head df.head, and then inside the parenthesis we are putting 10. And this is the first top 10 transactions of this data frame. Similarly, we can find the last 10 transactions or the last 10 observations of this data frame. So this is how we can find the last 10 observations or the last 10 transactions of this data frame using the tail function. If you want to find some random observation instead of the first 10 or the last 10, we can do using the sample function df.sample, and then provide inside the 10, let's say, and now it's randomly have picked the 10 observations from a given data set. And the last thing what we can do is find the shape. So we can see that we have 438,000 observations and 13 columns. Now in this question we also have been asked to find the statistical description, that we can do using df.describe, and we can see their statistical values like count, how many values are there, mean, standard deviation, mean value, what is the minimum value, and so on. If you want to know, by default it will only show you the numerical columns, but if you want to know the statistical analysis of all the columns, we need to put include equal to all. So the moment we put include equal to all, now it has included the categorical columns as well along with the numeric column. For the like categorical columns, it will tell you some different things like how many unique values are there, what are its top value, frequency, and so on. And for the numerical columns, it will basically tell you the mean value, 25 percentile, 50 percentile, and so on. Now the next question it's asking is that find the total number of observations in each category of operations type column. So we have a column called operations type, and what it's asking is that find out how many total number of observations are present in each of the category of this. So this operation type basically has two unique values, which is sale and return, and it basically asking that how many observations are belong to sale and how many observations are belonging to return. So we can do using the value underscore counts function. So let me copy the name of the column, dot value underscore counts, and it basically telling me that for sale we have this many number of observation, which is close to 437,000, and return has 349. We can do another thing is that instead of finding the absolute number, we can also find their percentage values as well, like what is a percentage. So for that it's very straightforward. We can do dot value underscore counts, and then inside we can mention normalize equal to true, and now it's telling me that 99.92% of the observations are belonging to sale, whereas for return it's less than 0.007%. So the next question is find the total number of null values in each column. First we have to count how many total number of null values in each column. and then pick one column and replace with that column with some median or the mode value. So let's first try to find out how many total number of null values are there in our data set, and in each of the column we can see that price and total due has both has 12 null values. Now the question is saying is that the question is saying that pick one of the column. Let's say in our example, let's pick one of the column as price and replace its null values with either mean value or a median value. So before we start, let's figure out which are those 12 null values are there. So df price dot is null. So we can see these are the 12 observations where the price column has null values or not a number of values. Now in order to replace, what we can do, so now let's replace all those null values, let's say with the median value. So the way we can calculate the median is df price dot median skip na equal to true. So what we are saying is that when you calculate the median value of this column, ignore the not a null values. And then the way we can replace df dot replace function and replace all the null values with median and then in place equal to true. And let's see how many null values are now. We are expecting it to be 0. Let's see. And we can say it's saying 0. So this is how we can replace any null values with a mean or median or the mode values. It's saying that create a list and input into pandas data frame. So let's create a list, and we are creating a 3 list and combining in this fashion. So this is our first list. Then we are passing the second list with 3 elements. Let's say Java, and we are creating another third list. Let's say Tableau. So we have created a list, and now from this list we will create a, let's say, data frame. ed dot data frame, and then we will pass this list, and then we can also pass the column names. So let's say the first column name we are giving ID, then let's say we are giving language, and the third would be, let's say, experience. And let's display using head. And we can see that with the list what we have created has converted into a pandas data frame with 3 columns in it. So the next question is aggregate the price column at month level and arrange in descending order. So what it's saying is that use the group by function and then show me what is the total amount of price at the monthly level. So before we find the group by at the monthly level, let's make sure check the data type of the date. Now here the date is showing to be object. So first let's convert into date time. So this can be done through pd dot underscore date time, and once it's converted, then let's extract the month. Let's extract the month from this date. dt dot month, and let's extract the year as well, so that if we need to do any analysis on the year, we should have this column as well. And we can see that month and year has been created. Now since the month is there, now let's do the aggregation here. So what I'm doing is I'm creating a month underscore price df dot group by. Now here I'm passing the dimension, which is month. Now here I'm passing the numeric column, which is price. Now here we are doing the aggregation based on, let's say, sum, and then I'm resetting the index, and let's say month underscore price, and we can see that it has been aggregated at the monthly level. And let's say if somebody wants to arrange in a decreasing order of a price, the way we can do is month underscore price dot sort underscore values by equal to, let's say, price, and let's say ascending equal to false. So we can see that month 3 has the highest total price, and then so on. So the next question is, now it's saying that load your second CSV file, and then once you load the second CSV file or a second data frame, then combine with the first table. So it means it's asking to do some kind of a merge or a join operation to join first table and the second table, and the output of it, there you have to aggregate the price by store city, aggregation the price by store city, and then arrange the store city by price. So let's do let's load the second CSV file, read underscore CSV, and then the name of the second file is store cities.csv, and it has been loaded. So let's preview the file or preview the data frame, and we can see that it's storing two columns, store number and the store city. So basically it's like a reference file for store numbers, and because our first table doesn't store cities, it's only have store numbers. Now the next step is to combine into one. So we can use the merge function to combine them. So df comma df1, and then on the column we can use store number, and it's saying how. So we can use the inner one, and let's preview as well. So after doing that, we should able to see the store city. So we can see that now the store city is coming here. Now the next step is to aggregate. So let's aggregate df2 group by, and it's saying that we have to do store city, aggregation at the store city. So the next is price, and then aggregate function, and here we are passing sum, and we can see that we have the store city now with their aggregated values. And this is for the sum. We can also find out about their minimum value. So we can find out what is the minimum price for that store city, what is the maximum price for that store city. So we can do that as well. So let's see what we will get, and we can see that for store city like Arizona, the total price is this much, and what is the minimum price and the max price. So this is how we can use the concept of aggregation, merging the two files into one, and then aggregating for some operations. So the next question it's asking is that find the null values in column called total due, and then display those transactions. And then once you find those transactions, then drop those rows and reset your index. So let's find out if whether so we can see that it has 12 null values in it. It has 12 null values. So the next part is, let's see which are those 12 null values in it. So the way we have learned is to pass the smaller one into the bigger df. So dot is null function, and we can see these are the 12 observations where the total du has a null values, nan values. So the next step is to drop those null values. So the way we can do is using the function called drop na subset equal to the name of the column, which is total du. We will pass x is equal to 0, because when we pass x is equal to 0, it basically will say that, you know, do some operations on the rows or the observations, and then in place equal to true, so that it can reflect the new changes in the existing data frame. And it has been dropped, so let's run this command again and see if the null values are coming to be 0, and we can see now the null values are 0. But the next part is we need to reset the index as well, because that is also very important. So the way we can reset the index, and then inside we will pass drop equal to true, and then in place equal to. So in this way it basically update the indexes as well. So now we can see that there are no null values, and this command basically will basically reset the index from 0 till the end. The next question is it's saying that we have to create a new column in our data frame, a new column, and the values of the new columns will be derived from the price column. So the way we will derive the values from the price column is based on certain conditions. So it's saying that if price is less than 50, then put low, or if price is greater than equal to 50 and less than 100, then put it as medium, else high. So the way we can do is let's say the name of this this column is price flag, and we will use the concept of apply in the lambda function. So df price dot apply lambda x, and then here I will create some function, and that function will basically do this if and else. So let's say I'm creating a function called price check and passing x here. So creating the function price check. Now here it will basically check if x less than 50, then return low, else it will check if x greater than equal to 50 and x less than equal to 100, then return medium, and else return high. So this, what will happen is that it will pick the first observation, the df price first observation, and then it will pass to this function price check. It will see whether that price value is less than 50 or greater than 50, and based on that it will assign the price flag, whether it's low, medium or high. Similarly, then it will iterate for second time, third time, for third price, and then fourth price, and so on. So before we run this command, make sure that you convert this into a int format, else you will get an error here. So probably another bracket, and now we have, I think it has ran successfully. We can see the new column has created price underscore flag with its value medium, low, and so on. So this is how we can create a new column from the existing one, and then we can also check the conditions, and based on the condition we will assign the values to a new column. The next part is we have to find out those observations in the data set where department is entering and the price is greater than 50. So the way we can use the conditional statement. So df department, and we can put it this first condition in the circular brackets, and then we'll put the end condition df price greater than 50. So let's put it this one as well, and it will show you only those observations where the department is entree and the price is greater than 50. We can also check, how many total number of observations are there. So we can put inside the length function length, and then it will tell you that, hey, there are 5,900 plus observations where department is entree and price is greater than 50. And the last part of the question is we need to find out the total number of sales and return in each category of department. So as you know that, let's see how many unique categories of department we have. Dot unique, and we can see that we have 4, 5, 6, 7, 8. We have unique 9 categories of department. Let's see in all those categories how many total number of sales and returns are there. So the way we can do, we can use the cross tab function. So we can pass df department, and then we can pass df operation type, because operation type is that column where we have the labels as sales and return. And we can see it's telling us that, hey, in the beverage we have 23 returns and more than 35,000 plus sale. And the gift cards, there is no return, but there is a sale of 731, and so on. So this is how we can find out the frequency count across different dimensions.